What if I told you there's a certification that could take your salary from $120,000 to $235,000 in less than 2 years? A certification so cutting edge that only a handful of professionals worldwide have mastered the technology it tests. A certification for the fastest growing AI skill in 2025, a skill that saw 985% job growth in just 1 year. I'm talking about NVIDIA Certified Professional in Agentic AI, the NCP-AI certification. If you've been watching AI agent demos on Twitter, wondering how those multi-agent systems actually work in production, if you're building with LangChain or LangGraph and want to prove your expertise, this video is for you. Today, I'm breaking down everything you need to know about the hottest AI certification of 2025, why multi-agent systems are exploding right now, and how to actually pass this exam without wasting $200 on a failed attempt. So, what exactly is the NCP-AI certification? It's a professional level credential from NVIDIA, the company that literally powers the AI revolution with their GPUs. The exam has 60 to 70 questions that you complete in 90 minutes. It's delivered online with remote proctoring, so you can take it from home. The cost is $200 and the certification is valid for 2 years before you need to recertify. Now, this is not a beginner certification. NVIDIA recommends 1 to 2 years of experience in AI or ML roles with hands-on work on production-level agentic AI projects. You should have strong Python skills, experience with frameworks like LangChain and LangGraph, and ideally you've already deployed at least one RAG system or multi-agent application. What does the exam cover? 10 domains ranging from agent architecture and design to building multi-agent systems to implementing RAG pipelines to deploying at production scale with NVIDIA's platform, and I am microservices, NeMo Retriever, NeMo guardrails. It also covers the stuff most engineers skip: safety, ethics, compliance, monitoring, and maintenance. Career-wise, this certification positions you for roles like AI engineer, solutions architect specializing in AI systems, or agentic AI developer, titles that barely existed 2 years ago, but now command $180,000 to $235,000 salaries. Industries hiring for this? Healthcare AI, financial services, cybersecurity, robotics, enterprise software. Anywhere that needs intelligent automation. When you pass, you get a digital badge you can add to LinkedIn and an optional physical certificate. But more importantly, you have proof that you can build the AI systems every company will need in the next 2 to 3 years. Let me break down the 10 exam domains so you know exactly what to study. Domain 1 and Domain 2 are tied for largest at 15% each: agent architecture and agent development. Agent architecture tests whether you can design multi-agent workflows. When do you use hierarchical coordination, boss agents delegating to worker agents, versus peer-to-peer coordination where agents collaborate as equals? How do you design communication protocols between agents? What orchestration patterns fit different use cases? Agent development is hands-on coding. Can you build an AI agent that uses tools? Can you integrate LangChain with external APIs? Can you engineer prompts that produce consistent, reliable agent behavior? Can you develop multimodal agents that handle text, images, and structured data? These two domains alone are 30% of the exam. If you don't have strong hands-on experience building agents, you will struggle. Domain 3 and 4 are tied at 13% each: evaluation and tuning and deployment and scaling. Evaluation tests whether you know how to benchmark agent performance, optimize system latency, run A/IB tests on different agent configurations, and continuously improve based on metrics. Deployment tests production skills. How do you containerize agents? How do you scale horizontally when traffic spikes? What infrastructure do you need for multi-agent systems? This is where theoretical knowledge fails. You need actual deployment experience. Domain 5 at 10%, cognition, planning, and memory. This is about reasoning patterns. When should your agent use React, which combines reasoning and action? When should it use tree of thoughts for exploring multiple solution paths? When is simple chain of thought sufficient? How do you implement persistent memory so agents remember past interactions? Domain 6 at 10%, knowledge integration and data handling. This is all about RAG retrieval augmented generation. How do you build a retrieval pipeline? What chunking strategy works for different document types? When do you use semantic search versus keyword search? How do you implement re-ranking to improve retrieval accuracy? Domain 7 at 7%, NVIDIA platform implementation. This is NVIDIA specific. How do you deploy models using NVIDIA NIM microservices? How do you implement semantic search with NeMo Retriever? How do you configure NeMo guardrails to prevent toxic outputs? These are precise technical questions. You can't guess your way through them. Domains 8, 9, and 10 are each 5%. Run, monitor, and maintain. How do you observe agent behavior in production? Safety, ethics, and compliance. How do you implement responsible AI guardrails? And human AI interaction. When do you require human approval in the agent workflow? A lot of engineers skip these soft domains and lose 15% of the exam. Don't make that mistake. The NCP-AAI is the only industry certification that validates production agentic AI skills. While others teach theory, this tests real-world system design. Script asterisk. You might be wondering, why get certified in agentic AI specifically? What makes this different from other AI certifications? Let me show you. Generic AI certifications from platforms like Coursera or Udemy teach you broad AI concepts. What is machine learning? What is neural networks? How do you fine-tune a model? This is valuable for beginners, but it's outdated theory. Most of this content is based on 2022 to 2023 technology. Cloud AI certifications, like AWS Machine Learning Specialty or Azure AI Engineer, teach you how to use managed AI services on those platforms. They're valuable if you're a cloud architect, but they don't teach you how to build multi-agent systems from scratch. They teach you how to click buttons in a console. The NCP-AI is completely different. It tests whether you can architect, develop, and deploy production agentic AI systems using modern frameworks like LangChain and LangGraph, implement RAG pipelines with NVIDIA NeMo Retriever, orchestrate multiple agents that work together, and deploy them at scale with proper monitoring and safety guardrails. This is not theory. This is, here's a scenario. Design a multi-agent system. Which coordination pattern do you use? How do you implement memory? What retrieval strategy works best? How do you scale this to 10,000 requests per second? And here's the key difference. The NCP-AAI is the only industry certification that validates agentic AI skills. AWS doesn't have an agentic AI certification. Azure doesn't. Google doesn't. NVIDIA saw where the market was going: multi-agent systems, RAG pipelines, production deployment, and created the first professional certification for it. When a hiring manager sees NVIDIA Certified Professional Agentic AI on your resume, they know you're not just prompting ChatGPT. You can build the intelligent automation systems their company desperately needs. Let me show you where agentic AI is being used in production right now, because this certification isn't about future technology. It's about systems that are live today. Healthcare, multi-agent diagnostic systems where one agent reviews the latest medical literature, another analyzes patient data, a third suggests potential diagnoses, and a fourth cross-checks everything against treatment guidelines. Mayo Clinic and Johns Hopkins are already piloting these systems. Financial services, fraud detection where monitoring agents flag suspicious transactions in real time, investigation agents analyze patterns across millions of accounts, compliance agents verify regulatory requirements, and alert agents notify human analysts only when necessary. JP Morgan and Goldman Sachs have invested hundreds of millions in this technology. Cybersecurity, autonomous threat response where detection agents monitor network traffic 24/7, analysis agents identify attack patterns, mitigation agents automatically block threats, and reporting agents document everything for compliance. CrowdStrike and Palo Alto Networks are leading this space. Retail and e-commerce. Personalized shopping assistants, where browse agents track what users look at, recommendation agents suggest products based on behavior and preferences, inventory agents check availability across warehouses, and support agents answer customer questions, all working together seamlessly. Amazon's entire recommendation engine is moving toward this architecture. Enterprise software. Automated customer support, where triage agents categorize incoming requests, knowledge agents retrieve relevant documentation, response agents draft personalized answers, and escalation agents hand off complex issues to humans. Salesforce and ServiceNow are building their next generation support platforms on multi agent systems. Research and development. Scientific research automation, where literature review agents scan thousands of papers, hypothesis agents propose new experiments, data analysis agents process results, and writing agents draft publications. Pharmaceutical companies like Moderna and Pfizer are using this to accelerate drug discovery. This isn't science fiction. This is happening now. And companies need engineers who can build, deploy, and maintain these systems. That's what the NCP-AI certification proves you can do. Let me break down the technology stack you absolutely must know to pass this exam. Foundation layer, you need strong Python skills. Not just I can write a for loop, I mean understanding async programming, error handling, production quality code. You need fast API for building APIs that serve your agents. And you need Docker for containerization because production deployment questions will test this. Agent frameworks, this is non-negotiable. LangChain is the most popular framework for building AI agents. You must know how to create chains, agents, and tools. LangGraph builds on top of LangChain for complex workflows and multi-agent orchestration. This is heavily tested, and you should be familiar with frameworks like CrewAI and AutoGen for multi-agent systems, even if you don't use them daily. NVIDIA platform, here's where it gets specific. NVIDIA NIM, microservices for deploying models at scale. NeMo Retriever, their semantic search and retrieval system. NeMo Guardrails, their framework for adding safety guardrails to LLMs. And AI Foundation endpoints for accessing NVIDIA's hosted models. Now, NVIDIA platform implementation is only 7% of the exam. But here's the trick. NVIDIA platform features appear in questions across all domains. A deployment question might ask how to use NIM. A safety question might test NeMo guardrails. An RAG question might involve NeMo Retriever. So, in reality, 40% or more of exam questions assume you know NVIDIA's tools. RAG and retrieval, you need to understand vector databases like FASS, Pinecone, or Weaviate. You need to know how embedding models work and when to use different models. You need to understand chunking strategies, how to split documents for optimal retrieval. And you need to know re-ranking techniques to improve accuracy, production, and monitoring. Gradio for building user interfaces. LangServe for deploying LangChain applications. Observability tools for monitoring agent behavior in production. Performance monitoring to track latency, throughput, and costs. If you're weak in any of these areas, you will fail this exam. It's not enough to have used LangChain once in a tutorial. You need hands-on production experience. Let me show you the question types that fail most candidates, because this exam is not straightforward. Challenge number 1, multi-agent coordination questions. Here's an example. A research company needs agents to collaborate on competitive analysis. Researcher agents gather data independently. Analysis agents need access to all collected data. A coordination agent prioritizes tasks. Which architecture is most appropriate? You might think, hierarchical. The coordination agent is the boss. But that's wrong. The question says researcher agents work independently and analysis agents need access to all data. That's a blackboard pattern where agents post to a shared workspace. This tests whether you understand coordination patterns at a deep level, not just definitions, but when to use each pattern based on subtle requirements. Challenge number 2, RAG pipeline design. A legal AI system must retrieve relevant case law from 100,000 documents. Documents range from 1 page to 500 pages. Users need precise citations. Which retrieval strategy provides the best balance of accuracy and performance? Candidate A might say, use small chunks for precision, but that creates millions of chunks, slow retrieval, and loss of context. Candidate B might say, use large chunks to maintain context, but then you lose precision and can't provide specific citations. The correct answer involves hierarchical chunking with metadata, plus a re-ranking step. But you'd only know this from production experience. Challenge number 3. NVIDIA platform specifics. Which NVIDIA NeMo guardrails rail type should be applied to filter retrieved chunks before they're used to prompt the LLM in a RAG scenario? If you haven't read NeMo guardrails documentation, you might guess input rails or output rails. But the correct answer is retrieval rails, a specific rail type designed exactly for this RAG use case. These questions are brutally precise. You can't fake knowledge of NVIDIA's platform. Challenge number 4, production deployment trade-offs. An e-commerce agent system experiences 10x traffic spikes during sales. Response time SLA is under 200 milliseconds. Which scaling strategy minimizes cost while meeting requirements? Option A, provision for peak capacity 24/7, meets SLA but wasteful cost. Option B, use auto-scaling, meets cost goals, but scaling takes 60 to 90 seconds, violating SLA during spike. Option C, implement caching with scheduled warm-up before sales. This is the answer, but only production engineers know that caching plus predictive warm-up is how you handle spiky traffic cost-effectively. These aren't trivia questions. These are architectural decisions that separate junior engineers from senior architects. Based on research and exam feedback, let me tell you why engineers fail this certification. Failure mode number 1, tutorial experience only. This is 40% of failures. You completed the NVIDIA Building RAG Agents with LLMs course. You followed a LangChain tutorial on YouTube. You built a simple chatbot. Then you book the exam thinking you're ready. You fail because the exam tests production challenges you've never encountered. How do you handle when retrieval returns no results? How do you scale horizontally when one agent becomes a bottleneck? How do you monitor multi-agent interactions? Tutorials don't teach this. Failure mode 2, weak NVIDIA platform knowledge. This is 25% of failures. You know how to build RAG with LangChain and Pinecone. That's great, but the exam asks specific questions about NVIDIA NIM deployment configurations, NeMo Retriever semantic search settings, NeMo guardrails rule syntax. You can't guess your way through these. You need hands-on experience with NVIDIA's tools. Failure mode 3, neglecting deployment and safety domains. This is 20% of failures. You're a strong developer. You can build complex agents, but you've never deployed to Kubernetes, never implemented monitoring, never configured guardrails. 18% of the exam tests deployment and scaling, run, monitor, maintain, and safety and ethics. That's potentially 12 to 13 questions you lose automatically. Failure mode 4, no multi-agent experience. This is 10% of failures. You built a single-agent RAG chatbot, but you've never orchestrated multiple agents working together. You don't understand hierarchical coordination, peer-to-peer communication, shared memory management. 15% of the exam tests agent architecture specifically for multi-agent systems. Without real experience, you're guessing. Failure mode 5, poor time management. This is 5% of failures. You have 90 minutes for 60 to 70 questions. That's about 1.3 minutes per question. If you're seeing these patterns for the first time, you'll spend 5 minutes per question trying to reason through them. You will run out of time. You need pattern recognition that comes from practicing with hundreds of realistic questions. Here's how to actually pass this exam in 8 weeks. Week 1, Agent Fundamentals. Study LangChain agent basics and LangGraph workflow concepts. Build a simple agent that can use tools, maybe a weather agent that calls an API. Take our practice exam 1 in untimed mode to establish your baseline. If you score 50% or higher, you have a foundation. Lower than 50%, you need more hands-on before continuing. Week 2, RAG development. Complete NVIDIA's Building RAG Agents with LLMs course. This is $90 and 8 hours, absolutely worth it. Build your own RAG pipeline with document chunking, embedding, and retrieval. Take practice exam 2 focusing on RAG scenarios. Target 60% plus. Week 3, reasoning and memory. Study reasoning patterns. React for action-oriented tasks, tree of thoughts for exploring multiple paths, chain of thought for step-by-step logic. Build an agent with persistent memory that remembers past conversations. Practice exam 3. Target 65% plus. Week 4, NVIDIA platform. This is critical. Get hands-on with NVIDIA NIM for model deployment, NeMo Retriever for semantic search, and NeMo guardrails for safety. Build a RAG system using NVIDIA tools specifically. Practice exam 4 tests NVIDIA-specific knowledge. Target 70% plus. Week 5, multi-agent systems. Study coordination patterns, hierarchical peer-to-peer Blackboard. Learn AutoGen or Crew AI for multi-agent orchestration. Build a multi-agent research system where agents collaborate. Practice exam 5. Target 70% plus. Week 6, deployment and production. Learn how to containerize agents with Docker, deploy to Kubernetes, implement monitoring and observability. Actually deploy something to production, even if it's just a personal project. Practice exam 6 tests operational knowledge. Target 75% plus. Week 7, safety and evaluation. Study how to implement NeMo guardrails, benchmark agent performance, prevent hallucinations, ensure ethical AI practices. Take practice exam 7. This is comprehensive covering all domains. Target 75% plus. Week 8, final review. Retake all practice exams until you consistently score 75% or higher. The exam doesn't publish passing scores, so you want a safety margin. Review your analytics dashboard to see which domains are weakest and focus there. Only schedule your exam when you're consistently hitting 75% plus. This is the path to passing on your first attempt and not wasting $200. Let me be blunt. You cannot pass this exam without extensive practice questions. And here's the data to prove it. Engineers who practice with fewer than 50 questions have a 35% pass rate. That's worse than random guessing on some question types. Engineers who practice with 100 to 200 questions have a 60% pass rate. Better, but still a coin flip. You're paying $200 to flip a coin. But engineers who practice with 455 plus questions, our complete practice test bundle, have an 85% or higher pass rate. Why such a dramatic difference? Because practice tests teach you 4 things that courses can't. Number 1, pattern recognition. After seeing 100 multi-agent coordination questions, you instantly recognize independent agents sharing data, Blackboard pattern. You don't have to reason through it from scratch. You recognize the pattern in 10 seconds. Number 2, NVIDIA platform specifics. The courses teach you concepts. Practice tests drill you on exact configurations, which NeMo guardrails, rail-type filters retrieval rails. How do you deploy a model with NIM? Use the specific API endpoint configuration. This precision only comes from repetition. Number 3, multi-agent scenarios. You've built one multi-agent system, but the exam gives you 20 different scenarios with different requirements. Practice questions expose you to hierarchical coordination, peer-to-peer, publish-subscribe, market-based, every pattern you need to recognize. Number 4, production trade-offs. Should you scale horizontally or vertically? Should you cache aggressively or recompute? Should you use provisioned capacity or auto-scaling? These decisions require experience with dozens of scenarios. Here's a real testimonial. I failed my first attempt after only doing the NVIDIA courses. They taught me theory, but not how to make architectural decisions. Preparato's 455 practice questions taught me the thinking the exam actually tests. Passed my second attempt with room to spare. Alex M., AI engineer. This is the difference between theory and application. Our practice test bundle has 7 full exams, matching the actual 60 to 70 question format and 90-minute time limit. 455 unique questions across all 10 domains, and detailed explanations for every answer. Not just why the correct answer is right, but why each wrong answer fails. This is how you build the pattern recognition that separates passing from failing. Let me show you the career trajectory after getting certified. Before certification, you're a software engineer or ML engineer making $100,000 to $120,000. You have basic Python skills, maybe some ML experience from a bootcamp or online course. You've built tutorial-level chatbots, but nothing in production. Month 2 after passing. You're now qualified for AI engineer positions at the junior level. Salary jumps to $120,000 to $140,000. You have verifiable skills in LangChain, RAG pipeline development, and NVIDIA's platform. You've deployed at least one production RAG system. Your LinkedIn shows NVIDIA Certified Professional. Month 6 with experience. You're a mid-level AI engineer now. Salary range: $140,000 to $180,000. You've built multi-agent systems, deployed them at scale, and solved real production challenges. You're getting recruiter messages daily. Month 12 to 24, Senior AI Engineer or AI Solutions Architect. Salary: $180,000 to $235,000. You're designing enterprise-scale agentic AI platforms, leading teams, making architectural decisions, and the industries hiring for this are high-paying. Healthcare, AI, medical diagnostic systems, clinical decision support. Salary range: $160,000 to $220,000. Finance, algorithmic trading agents, risk assessment systems, fraud detection. Salary: $180,000 to $235,000. Enterprise SaaS, building automation platforms that replace manual workflows. Salary: $150,000 to $200,000. Robotics and autonomous systems. Warehouse automation, logistics manufacturing. Salary: $170,000 to $210,000. This certification isn't just a resume line. It's a $50,000 to $100,000 salary increase over 12 to 24 months. The question isn't whether you can afford to invest in preparation. It's whether you can afford not to. Here are your exact next steps to get certified and accelerate your career. Step 1. Assess your current level. Go to preparato.com and take our free sample questions. No credit card required. This will show you exactly what the exam tests and where your knowledge gaps are. Step 2. Get the practice bundle. 7 full practice exams with 455 questions covering all 10 domains. Compare that to the $200 you'll waste on a retake if you fail. This is the best $20 investment in your career. Step 3. Follow the 8-week study plan I outlined earlier. Study systematically, build hands-on projects, and take practice exams weekly to track your progress. Your goal is 75% or higher on all practice exams before booking the real exam. Step 4. Schedule your exam only when you're consistently hitting 75% plus on timed practice tests. Don't schedule based on hope or completing a course. Schedule based on data. Go to NVIDIA's website and register through the Certiverse platform. The exam costs $200. Step 5. Pass the exam and accelerate your career. You'll receive your NVIDIA Certified Professional digital badge, which you add to LinkedIn immediately. Start applying for AI engineer roles at $180,000 to $235,000. Build cutting-edge agentic AI systems. Be part of the AI revolution. Don't wait. AI agent job postings increased 985% last year. This opportunity won't last forever. The engineers who get certified now will have a 2-year head start over everyone else. If this video helped you understand the NCP-AI certification, smash that like button and subscribe. I'm releasing deep dives on AWS certifications, cloud architecture, and AI engineering. Drop a comment. Are you planning to get the NCP-AI certification? What's your current experience with Agentic AI? See you in the next video. Now go build something amazing.